This is SpaceTime Series 23, Episode 49. Coming up on SpaceTime. Stunning new images from the surface of the asteroid Ryugu. Scientists find what they think could be the first known extraterrestrial protein inside a meteorite. And a Russian rocket mysteriously breaks up in orbit, and no one's really sure why. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have released amazing new close-up high-resolution images and video from the surface of the asteroid Ryugu. The stunning new images have revealed a chaotic, boulder and rock-strewn landscape of incredibly rugged beauty. They were taken by the Japanese Aerospace Exploration Agency's Hayabusa 2 spacecraft as it briefly touched down on the asteroid's surface to collect samples. Ryugu is a potentially hazardous near-Earth object, or NEO, belonging to the Apollo group of Earth-crossing asteroids. The 950-metre-wide diamond-shaped space rock is a rare spectral-type CG asteroid, which includes properties of both common carbonaceous or high-carbon content C-type asteroids and relatively rare G-type asteroids, which contain strong ultraviolet absorption features suggesting phyllosilicate minerals such as clays and mica. Ryugu circles the Sun in retrograde every 474 Earth days between the orbits of Earth and Mars. The detailed new observations of Ryugu's surface will help astronomers understand the age and geologic history of the asteroid. Previous observations have shown that Ryugu's surface appears to be composed of two different types of materials, one slightly redder and the other slightly bluer. But during Hayabusa 2's landing, its thrusters kicked up a coating of dark, fine-grained matter which appears to correspond with the surface's redder materials. And by relating these observations with the stratigraphy of the asteroid's craters, astronomers speculate that the surface reddening could have been caused by rapid solar heating during an earlier orbital excursion which took the asteroid closer to the Sun. A clear and disturbing sign that this asteroid can change its orbit. The Hayabusa 2 mission launched aboard an H-2A rocket from the Tanegashima Space Center south of Tokyo back in December 2014, arriving at Ryugu in June 2018 following a 300 million kilometer journey. The 609 kilogram spacecraft was equipped with multiple science payloads designed to study the asteroid's geology, chemical composition, its structure, early history, and evolution. Ryugu also deployed 4 tiny lander rovers during its 18-month visit. These were designed to study the asteroid's surface mineralogical composition, its thermal behavior, and its magnetic properties. Hayabusa 2 departed Ryugu back in December 2019 and will swoop down past the Earth at the end of this year, ejecting its sample return capsule, which will land in the Woomera rocket range in outback South Australia. By the way, that name Ryugu, well, it means Dragon Palace in Japanese. And it refers to a magical underwater palace in Japanese folklore, where a fisherman once travelled on the back of a tortoise, returning home later with a mysterious box, much like Hayabusa 2 returning to Earth with its asteroid samples. This is SpaceTime. Still to come, scientists believe they've found what they think could be the first known extraterrestrial protein discovered inside a meteorite, and a new study claims gas giants are formed differently to the way brown dwarfs are formed. All that and much more still to come on SpaceTime. Okay, let's take a break from our show for a word from our sponsor, The Great Courses Plus. You know, learning new things helps us see the world from different perspectives, which in turn helps us make sense out of this ever-changing world. And the Great Courses Plus streaming service is an excellent resource to expand your knowledge, allowing you to gain valuable, reliable insights on a huge range of subjects from some of the world's best teachers. Now, these people are real experts in their field, and they include some of the world's leading scientists and researchers, people who not only know the topics, but who actually wrote the textbooks. We're not just talking about science either. The Great Courses Plus has courses on history, art, music, architecture, even cooking. In fact, you'll find subjects in the Great Courses Plus that you didn't even know you liked, stuff you would never have considered before. But that's what the Great Courses Plus does. It opens your mind to new concepts and new ideas. And the best part about the whole thing is, it's a great way to learn while at home. You can stream it on TV and watch it as a family, or listen to the Great Courses Plus app while you're out in the garden or taking a walk around the neighbourhood. Now, there's a new course on exoplanets I want to tell you about this week. It consists of 24 lectures, and it takes you on a journey through these exotic new worlds in distant parts of the universe. And by signing up to the Great Courses Plus through our special URL, you can check it out for free. So, what have you got to lose? It's a free trial for SpaceTime listeners, giving you unlimited access to the entire Great Courses Plus library, thousands of courses to browse through and listen to. And you can start by signing up today through our special URL at thegreatcoursesplus.com/space. That's thegreatcoursesplus.com/space. And of course you can find those URL details in the show notes and on our website. That's thegreatcoursesplus.com/space. And now, it's back to our show.
You're listening to SpaceTime with Stuart Gary.
Scientists have found what they think could be the first known extraterrestrial protein. A report on the pre-press physics website archive.org claims the protein was discovered inside a meteorite. It's been provisionally named hemolithium and was identified in two carbonaceous chondrite meteorites, ACFA 086, which crashed down to the ground in Algeria in 1990, and in one of the Alendi meteorites, which fell to Earth in northern Mexico and southwestern United States during a meteor shower in 1969. Proteins are large biomolecules or macromolecules consisting of one or more long chains of amino acid residues. They perform a vast array of functions within organisms, including catalyzing metabolic reactions, DNA replication, responding to stimuli, providing structure to the cell and organisms, and transporting molecules from one location to another. Scientists identified the potential extraterrestrial protein using a new high-precision mass spectroscopy technique. Hemolithium consists of chains of the amino acids glycine and hydroxyglycine, as well as iron, oxygen, and lithium atoms. The clue that this could be a protein of extraterrestrial origins, rather than something which simply contaminated the meteorite after it arrived on Earth, was its deuterium to hydrogen ratio, which was some 26 times greater than that found on Earth and consistent with the composition of long-period comets. Hydrogen atoms are composed of a nucleus made up of a single proton orbited by an electron. But deuterium, which is a heavier isotope of hydrogen, also includes a neutron in the nucleus. The study's lead author, Malcolm McGeoch from PlexCorp, says this type of deuterium enrichment simply doesn't appear in amino acids on Earth, and so indicates a protostellar disk or molecular cloud origin. Evidence of complex extraterrestrial chemistry has been found before. Amino acids, which are the building blocks of proteins, as well as polycyclic aromatic hydrocarbons, sugars, ribose, cyanide and tholines have all been detected either in comets, meteorites, or just simply floating around in space. In 2017, scientists found entirely new organic compounds in the famed Murchison meteorite, which crashed down in Victoria. But this is the first report of a protein of extraterrestrial origin. However, it's worth pointing out that hemolithium may not be a protein at all, but rather a polymer, a broad class of molecules that include proteins. Another problem is that the amino acid hydroxyglycine has never been detected in any meteorite before, although admittedly that doesn't mean it couldn't be there. Of course, hemolithium isn't evidence of alien life. Its discovery, if confirmed through peer review, would simply show that very complex chemistry, of the sort needed for life as we know it, can occur in places other than Earth. Scientists have long hypothesized that the ingredients for life may well have arrived on Earth in meteorites and asteroids, and finding a tiny protein buried deep inside a meteorite would provide added support to that hypothesis. To find out more, Andrew Dunkley is speaking with astronomer Professor Fred Watson.
This is the discovery of the first ever protein found in a meteorite, extraterrestrial protein. That is the key word in this, extraterrestrial. Now, I know what some people might think. I'm sure some of the press went, "Oh, we found aliens," but I suspect it's something else.
Well, it's a pointer to aliens, I guess. It doesn't mean that it's not evidence of alien life of any kind, but it is one further step in the notion that the complex molecules that make up living organisms may have their origins in space. It's an interesting story, the fact that something was observed a long time ago and it's more recently been followed up with other equipment to get a different answer. It comes about because of analyses of meteorites that are actually in museums. Basically, there were 2 meteorites involved in this story. Their names are not really important. I think one was found in the Middle East. Some years ago, these meteorites were analysed, and what was found were the complex molecules. They found things like ribose, which is a type of sugar, and it's found in RNA, and amino acids. These are basically the building blocks of proteins. So people knew that already. These molecules had already been found in these meteorites. But what has now happened is that a new superconductor X-ray source has been used. It's a mass spectrometer, a thing that measures the masses of molecules. This is new technology, Andrew, and that's kind of what's pushed this research further forward. And it actually, in fact, it's really interesting because some of the authors of this work are actually connected with the company that builds the equipment rather than academic university. Although I've got the paper in front of me, and it has actually 1, 2, 3 authors, and I think 2 of them are from the commercial companies. I might have that wrong. I should check it more closely, so don't write in if I'm wrong. But the bottom line is...
they will. You know they will.
Yeah. The bottom line is that with this new equipment, the complex molecules have revealed more details about their nature. There is an independent comment from an astronomer basically here in Australia. He's a chemist, astronomer. Oh, sorry, might be a she. Yes, it is a she. I beg your pardon. It's the CSIRO here in Australia. And the quotation is, in general, they're taking a meteor that has been preserved by a museum and has been analysed previously, and they're modifying the techniques that they're using in order to be able to detect amino acid inside this meteor, but with a higher signal-to-noise ratio. This is the yardstick by which we judge all our measurements, whether they're astronomical or bits and pieces of meteorites. It's all about the signal-to-noise ratio. And so what the team found were an amino acid called glycine, and that came in with a stonking great signal that wasn't present in the earlier analysis. But they also found that this glycine had other chemical elements attached to it, iron and lithium. And basically, they realized that this glycine wasn't just an isolated amino acid, it was actually part of a protein, which they've given a name. It's hemolythin is what they're calling it. So there's a comment that hemolythin is actually similar to proteins we find here on Earth. But, and this is the clincher to all this, it's the ratio of deuterium to hydrogen, that's heavy hydrogen to hydrogen. That is a ratio that is only found in long-period comets. You don't find it in the terrestrial version of these proteins. So this protein has got the atoms within it are definitely from outer space. And so that's, as I said, it's the clincher.
So bottom line, it's a protein that's associated with what we refer to as a building block of life, and it's come from somewhere else.
That's the bottom line, exactly.
So, as they say, not proof of extraterrestrial creatures, but proof that the building blocks are out there.
Yes, that's right. Yeah, and these are complex building blocks. They're proteins. As far as life on Earth is concerned, that life basically always involves proteins. So it's a really interesting discovery. The paper that has been written on this, the paper's entitled Hemolythin, a meteoritic protein containing iron and lithium. I have read the abstract of that, I haven't read the paper. It's fairly complex stuff. My life science skills are pretty basic, I have to say. They're limited to stroking the cat, as you know. That's as much as I know about life sciences. But you get the drift of it from the abstract in the paper, and that's the bottom line. This is all about the isotopes that have been found and that signature that tells you that this is extraterrestrial.
That's Dr. Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is SpaceTime. I'm Stuart Gary. Still to come, a new study claims gas giant exoplanets are formed differently to brown dwarfs, and a Russian rocket is mysteriously broken up in orbit, and no one's really sure why. All that and much more still to come on SpaceTime. A new study claims that gas giants are formed differently to the way brown dwarfs are formed. Brown dwarfs are failed stars, objects which don't have enough mass to sustain the core hydrogen fusion process which makes regular stars like our Sun shine. However, some brown dwarfs can fuse deuterium and lithium under the right conditions. While many brown dwarfs are born as brown dwarfs, others start their lives as spectral type M red dwarf stars, which have lost enough mass during their evolution to cease the core nuclear fusion process, turning them from red dwarfs into brown dwarfs. Brown dwarfs fit into this unusual category between the very largest known planets, which have about 13 times the mass of Jupiter, and the smallest known stars, spectral type M red dwarfs, which are about 75 to 80 times the mass of Jupiter, or if you prefer, 0.08 solar masses. Astronomers believe brown dwarfs form in the same way stars do, through the gravitational collapse of molecular gas and dust clouds. On the other hand, planets are formed in protoplanetary disks around stars, initially through electrostatic attraction of tiny dust and grain particles, and then as they get bigger through the accretion of nearby gas and other material left over from the star-forming process. The study's lead author, Brendan Bowler from the University of Texas at Austin, says while previous research has shown that brown dwarfs orbiting stars likely formed like low-mass stars, it's been difficult to determine exactly how low in mass an object formed through this process can be. To try and answer that question, Bowler and colleagues combined archival data with their own observations using the Keck and Subaru telescopes to study the orbits of brown dwarfs and gas giants in 27 planetary systems. They then combined these observations with computer modelling based on Kepler's laws of planetary motion in order to fill in the gaps in their data caused by the many years, decades and centuries it takes some brown dwarfs and gas giants to complete a single orbit around their host star. Bowler believes the key was in determining the shape of the orbit. He postulates that objects with more circular orbits probably formed like planets, while those with more elongated orbits probably formed like stars. He says that's because if a clump of gas and dust is collapsing to form a star but then suddenly splits into two separate clumps, one forming a star and the other forming a brown dwarf orbiting that star, then the less massive brown dwarf would have a more elongated orbit. And Bowler found that he was accurately able to determine if an object greater than around 15 Jupiter masses was a giant planet or a brown dwarf simply by observing the shape of their orbit. The findings are reported in the Astrophysical Journal. This is SpaceTime. Still to come, a Russian rocket mysteriously explodes in orbit, and later in the science report, we ask the questions no one else will ask, like where do southern right whales spend their summers? All that and much more still to come on SpaceTime. The Russian Federal Space Agency Roscosmos says one of its rockets has mysteriously broken up in orbit high above the Indian Ocean. The frigate SP Upper Stage had been used to launch a Spectre R radio telescope into orbit back in 2011. The US Air Force 18th Space Control Squadron says instead of a single object, it's now tracking 65 separate fragments. There's no indication as to what caused the mysterious disintegration. The breakup is adding to the ever-growing problem of space junk in orbit around the Earth. The United States is currently tracking more than 18,000 artificial objects in orbit. Now, of those, only around 2,000 are operational satellites. The rest are disused spacecraft and spent rocket stages. But you got to remember, these are only objects large enough to be easily tracked from the ground. Current estimates suggest there are somewhere around 950,000 bits of space junk a centimetre or more in size also orbiting the Earth, as well as a staggering 170 million bits of debris a centimetre or smaller in size. And the thing you've got to remember is that these objects are all travelling at orbital speeds. That's 28,000 kilometres an hour or faster. This is SpaceTime. Still to come, the science report and evidence that the COVID-19 virus is present in semen from patients with the illness, and new research showing that temperature and latitude don't appear to be associated with the spread of COVID-19. All that and much more still to come on SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. Scientists have discovered that the COVID-19 virus can be present in the semen of patients with the illness, and it can also be present in the semen of recovering patients. The findings, reported in the Journal of the American Medical Association, opens up the possibility that COVID-19 could be sexually transmitted. The deadly disease, which originated in the horrific wet markets of China's Wuhan province, has now killed more than 300,000 people and infected over 4.5 million others. A new study shows temperature and latitude don't appear to be associated with the spread of COVID-19, but school closures and other public health measures have been having a positive effect. The findings, reported in the Canadian Medical Association Journal, are based on measurements of the number of cases recorded in 144 regions across the world during 2 days in March. Researchers tested the relationship between case numbers and latitude, temperature, humidity, school closures, restrictions on mass gatherings, and social distancing. Countries such as China, Italy, and South Korea were excluded because of the intensity of their outbreaks during the time of the study. The results found little or no association between latitude or temperature with the spread of COVID-19, and only a very weak association between humidity and transmission. On the other hand, school closures, social distancing, and restrictions of large gatherings were highly effective. Hackers working for Iran's Islamic Revolutionary Guards have carried out a series of cyber attacks targeting US drug maker Gilead Sciences. Gilead's the company which developed the experimental drug remdesivir, which is being used to fight the COVID-19 coronavirus. America's Food and Drug Administration approved the drug last week for emergency use with COVID-19 patients. Southern right whales migrate around Australian and New Zealand coasts according to the seasons, but exactly where these whales spend their summers has only ever been inferred by historic whaling data. In order to improve science's understanding of this migration, researchers tracked 6 whales using satellites in order to monitor their journeys from their wintering grounds. They found the whales were travelling distances which ranged from 645 kilometres up to a staggering 6,381 kilometres over an average of 78.5 days. A report in the journal PLOS One identified likely foraging grounds to the southwest of Western Australia, as well as Antarctic waters and the Subtropical Front. The Subtropical Front can be traced from around 40 degrees south latitude in the Indian Ocean across the Great Australian Bight, passing just south of Tasmania and New Zealand's South Island, before continuing back at 40 degrees south latitude across the Pacific Ocean. Scientists say the Subtropical Front appears to be the preferred summer feeding ground for both Australian and New Zealand southern right whales. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from SpaceTimeWithStuartGary.com, or from your favourite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through SpaceTimeWithStuartGary.com for all the details. If you want more space time, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.